this problem for you. This is an exam question for people who are either taking the circuits technical exam of PEng, or the second year undergrad students who are basically preparing for a midterm in the circuits course of the second year, or the final exam. Okay, so the question asks, for the circuit shown in figure 1, calculate the equivalent resistance of the circuit RAB at the terminals A and B. Okay, so right here, this is where we want to basically look at things. Right here, let's call this RAB. Okay, so this RAB, whatever it is going to be this 10 ohm, the one that we see here, this 10 ohm, in series with whatever we see from this point on. Okay, so I'm going to delete this part and then call this RT1, for example. So RAB, not a good color, this one, RAB is 10 ohm in series. So when we say in series, it means that the total resistance is going to be the summation of the two. So right now we are assuming that this is our 50 volt, and this is our 10 ohm, and this, whatever we are seeing from this point on, is our RT1, basically. Okay, so we are replacing all of this with RT1. Okay, and this is where things are getting complicated. Okay, because when you look at it right now, nothing is exactly in series or in parallel the way we know it, right? So we have to find out what is our RT1 from this point on. So let's look at RT1 right here. What we have is 120 ohm that goes between this point and the ground, and then we have 5 ohm, and then we have another 10 ohm, and then another 10 ohm. I'm just repeating the circuits but I'm dissecting it to two sections: the 10 ohm that was simple, and then also the more complicated part of the circuit, this part, 12 ohm. Okay, so when you look at this, RT1 is not very straightforward, right? We want to find RT1 and we don't know how it is. If you look at this part, let's look at the 10 ohm that we have here, the 12 ohm here, and then the 25 ohm here. Let's not look at this one. 25 ohm here. Okay, when you look at it, they all have this node in common, and actually from this node on, you can say at this node of, let's call it N, node N. Okay, at node N, we have a 25 ohm that goes to the ground. Then we have a 10 ohm that goes somewhere else. It's actually important to name these nodes. So let's call this node N1, N2, this is N, this is N3. Okay, later when we are going to replace these ones back, they come in handy. This is N1, let's call this N2, and then we have 12 ohm that goes to N3. Okay, this looks like a basically composition of resistors. We can replace them with the triangle composition. So all these three can be replaced by what we call, let's call this R1, R2, and then R3. This formula is given to us in the exam, at the end of the exam, basically. I'll show you right here. So if you go at the end of it, this is the star delta conversion. This is actually given to us. Okay, so it says if you have Z1, Z2, Z3, you can replace all of these by ZA, ZB, ZC, as long as they follow these. It's a very simple formula. Don't let it scare you. What this one says is that, first of all, multiply all two combinations, Z1, Z2, Z2, Z3, Z3, Z1. What are you dividing it by? ZA, look at ZA. ZA is between Z2 and Z3, right? You're dividing it by the one that is far away from ZA, which is Z1. ZB, look at ZB, is going to get divided, the multiplications, to Z2, because Z2 is the one that is not impacting ZB. So you're kind of taking it away from this. So this is how we can basically find R1, R2, R3. Let's practice it together. First of all, I need the multiplication of all of these. I'm going to call this value like R prime, for example. Okay, R prime 2, whatever you want to call it. It's 10 ohm multiplied by 12 ohm plus 10 ohm multiplied by 25 ohm plus 12 ohm multiplied by 25 ohm. Okay, when we add all of these together, and remember, we need this one because what we need this number because what we are going to look is R1 is going to be R prime 2 divided by what? By the number, the resistors that is not relating and that is not impacting R1. R1 is between 10 ohm and 25 ohm. So we are going to get this divided by 12 ohm. So this is 120 plus 250 plus, how much is this? 250 plus 300. So this is going to be 670 ohm. So 670 over 12 is going to be R1. R2 is going to be R prime 2. Let's look at it. R2 is between 12 and 25. So the 10 ohm is the one that is not impacting R2. So we're going to divide this by R2. So 670 over 10. This is easy, 67. R3 is R prime 2 over, you guessed it, the other one, 25, the last one, 670 over 25. Okay, so now 670 over 12, this is 55.83 ohm. Then we have 670 over 25. This is 26.8 ohm. This is a very long solution, so bear with me. Okay, so now we can replace our 10 ohm, 25, and 12 ohm by the delta conversion. Okay, so now this is the part that you have to be very careful because that's where the mistake can happen. Okay, so let's look at them. I'm going to, I have a math assistant. Okay, so I'm going to convert this. I'll bring it right here because it's easier. So let's keep RT1. We have 20 ohm. Look at this ohm, 20 ohm then we have the 5 ohm, then we have the 10 ohm. These are the ones that we're keeping from before, right? These three, 12, 10, 25, have to be replaced by these. But how? Remember that between N1 and N3, we have R3. So we have to put that here. N1 is right here at the 5 ohm. This is our N3. Okay, and then we have our N1. This is our N1. And then we have our N2, which is basically the ground. N2, which is ground. That's why it's very important to look now. So between N1 and N3, we have our R3. R3 is 26.8. So here comes 26.8 ohm. Then we have between our N1 and N2. N1 and N2 is here. This is going to be N1 and N2, R1. R1 is 55.83. This is our R1. Between N1 and N3, it was our R3. Now, all is left is R2. R2 is between N3 and N2. Did I do this right? Yeah. So, okay, and then we have an R2 is here. R2 is right here. We are going to put N3 and N2, sorry. I confused myself. We have, we replaced R3, R1, and R2. R2 is between N2 and N3, yes, R2. For now, I'm gonna put the value here, okay? Let's reorganize this a little bit. So now we have 20 ohm. And then we have our R2, which is 67 ohm. Then we have our 5 ohm, which is in parallel with our 26.8 ohm. Then we have our 10 ohm, which is again in parallel with 55. I said 55 and I wrote 22. Go figure. 55.83 ohm. Okay, so now we can see some stuff are coming together. Okay, now these two are in parallel, right? When we have 10 ohm is in parallel with 55.83. When these are in parallel, 10 multiplied by 55.83 over the summation. Let's see if okay. Okay. I was trying to see if it would help me. So now I'll figure it out later. So we have 558 over 83 dot 83 over 65.83. That's about 8.5 ohm. Okay, and remember the total resistor of two resistors that are in parallel to each other is always going to be less than the value of each of them. So the summation of the result of 10 ohm in parallel with 55.83 is always going to be less than 10 ohm because it has to be less than both of them. Okay, so this is going to be replaced by 8.5 ohm. Now let's do the other one. Let's do, for example, this one. Again, you guessed it. These two are in parallel and the value is going to be less than 5 ohm. So this is going to be 26.8 multiplied by 5, 26.8 plus 5. So that's going to be 26.8 multiplied by 5 over 31.8. That's about 4.2 ohm. We already knew that it's going to be less than 5 ohm, so no problem there, right? So 4.2 ohm. Okay, now we have to go one more time. Again, we are replacing a step by step. 20 ohm, then we have 67 ohm, then we have our 4.2 ohm, then we have 8.5 ohm. Now these two are in series, so they're going to add up. Plus 4.2 plus 8.5, I can do this. 12.7, and then this 12.7 ohm is going to be in parallel with the 67 one. So again, don't forget this is our T1. So one more time, one more step. Actually, let's do it clean. So one more time, we are going to do this 20 ohm, 67 ohm, and this is our 12.7 ohm. You can, even at this stage, you can say all three of them in parallel, but let's do just two resistors at a time. This is going to be 67 multiplied by 12.7 over 67 plus 12.7. Okay, so 67 multiplied by 79.7. That's 10.7 ohm. We already knew it has to be less than 12.7, and then RT1 is going to be 20 ohm in parallel with 10.7 ohm. That is going to be 20 multiplied by 10.7, 10.7 plus 20. $6.97 ohm. Are we done? No. Let's go back. This was only part of our solution. We said RAB, don't forget to do the last step. RAB was 10 ohm in series, so plus our RT1. So 10 ohm plus 6.97 ohm. So it's going to be 16.97 ohm. This is our RAB. Okay? The second part of this question says when 50 volt DC source is switched at terminals AB, solve for the voltage V1 at the location shown. Okay, I was strategic in trying to find RT1. Why? Because now I can say this circuit is equal to, oops, what did I do? I can say this circuit is equal to, when the 50 volt is connected, 50 volt plus 10, this is the 10 ohm resistor, and this is my RT1. RT1, and then V1 is actually the voltage across RT1. So in order to find V1, all I need to do, this is the second part of the question. V1 is exactly the voltage divider. We can use the voltage divider formula, 10 ohm plus RT1 multiplied by 50 volt, which we already found. RT1 was 6.97 ohm. So 6.97 over 10 ohm plus 697, 50 volt. And that is going to be so 6.97 over 16.97 multiplied by 50 volt. That's about 20.53 volt. So you see, just as we only needed a simple voltage divider, right? But the score or the points is 10 and 10. Because we did all of this work, that we were able to get the second 10 points so simply by just doing the voltage divider. So especially with these questions, try to go ahead and like solve it systematically, because there's always a point or a part that you would need later for to do the second parts. At least that's how a teacher or an exam designer would design it, so that like, you know, as you're proceeding, progressing through the questions, you don't have to do everything from the beginning. Otherwise, like, you wouldn't have enough time. Usually the first part is the most work of all of the questions. Okay, I hope this was helpful, and see you next time.